this question, we have two skaters and both of them, they have a mass of 50 kg and they are approaching each other along the parallel paths, and these their paths, they are separated by a distance of 3 meters. They have equal and opposite velocities of 10 meter per second. So velocities are given, their mass is given, and the separation is also given. One of them, that is, he holds a long pole 3 meter long, that is, the separation is 3 meters, so that's a length of the long pole. The first skater carries a long light pole, that is, mass of pole is equal to 0 and its length is 3 meter. And the second skater, as soon as the first skater reaches the second skater grabs the end of the pole, and that's why now they shall be moving in a circle only, that is, with some angular velocity. And after some time, these two, both of them, they pull the poles towards each other, and as a result, the distance between them is reduces by 1 meter. So initially, if the distance is 3 meter, now it reduces to 2 meter. We are asked, that is, as soon as this person, the second skater, grabs the pole, what is the angular velocity? And then when the distance reduces by 1 meter, then what is the angular velocity? And if there is increase, why there is an increase in angular velocity, or if there is a decrease, why there is a decrease in angular velocity. So this is the question. Look over here, if you are looking at the top, it is the skater number 1, which is going this way with the velocity v and holding the pole like this. So this is the person who is going in this direction it is going, and from there the other person is coming perpendicular to this length, and when it comes over here, it grabs the pole. So we are looking at the top. So this person is mass m, that is, it is 50 kg is given, going with velocity, that is given. This length 2l is 3 meter, that is also given, and from here perpendicular to this is the second skater comes and grabs it. We see that is the momentum of this is in this direction, momentum of this is in this direction. So net momentum vector is going to be equal to 0. Whatsoever the momentum of this is in this direction, the same is momentum in this direction. So as a result, the net momentum when the collision takes place, whether he holds it or collision, that is the same principle, they will hold good. So the net momentum will remain same. So along the y-axis, if you see from the top, and let's call it as this is y-axis and this is x-axis over here. So we see along the y-axis, the initial momentum is equal to 0. So it means the final momentum should also be equal to 0. So as soon as he holds it, the center of mass will remain stationary. The center of mass will not have any acceleration. It will continue to have a 0 acceleration. So that is, if this is going to have velocity v, this will also have velocity v. So the whole thing will rotate with angular velocity omega. So this will also have tendency to rotate this way. This also have tendency to rotate it this way. So both of them, they have a tendency to rotate it this way. Now comes to angular momentum. So it means about this c, the angular momentum is also conserved. It means I1 omega 1 is equal to I2 omega 2. That is mv into L. About c, if we talk about, and we conserve the angular momentum about c, if we conserve it, so mv, total length is 2l, so mv into L. This is the angular momentum of this, about this, plus mv, linear momentum. Angular momentum is movement of momentum, linear momentum into this distance, that is mv into L. This is also in this direction, this is also in this direction. Both of them, they are in the clockwise direction, so they are get added up. So total momentum is mvl plus mvl is equal to I omega. I into omega, that is initial angular velocity. As soon as it grabs it, then that is the angular velocity we shall be getting right now. That is 2 mvl is equal to 2 into, that is I omega. I of what? I of this plus I of this. I of this is what? M into L square. I of this, about this x is what? M into L square. Total length is 2L. This is L. So M into L square for a particle is mr square. So it is 2 into ml square into omega. From here we get omega as 20 radian per second. So this is, as soon as it holds it, it comes out to be 20 radians per second. About this, it shall be rotating with angular velocity 20 by 3 radian per second. Now when this and this person, they pull towards each other through this pole, then and the distance goes from 3 meter to 2 meter. Now it has gone. It means initially this distance was 1.5 meter. if total is 3 meters, so it means 1.5 meter is from here to here, 1.5 meter is from here to here. So now it is 2 meter, so it means this person has come over here and this person has come over here, and the distance is reduced by 1 meter. So it means now this has reduced from 1.5 to 1 meter, and this also has reduced from 1.5 to 1 meter. Half meter goes from here, half meter goes from here. So total distance is now, it's a 2 meter, right? So because there is no external torque onto this system, so it means the angular momentum will remain conserved. So I1 omega 1 is equal to I2 omega 2. So I1 omega 1, omega we have found it. So I into omega is equal to I dash into omega dash. What is I into omega? I into omega is, that is I of 1, that is m into L square. Total initially we had taken as 2L, where 2L is equal to 3 meter. So ml square for 1, for 2 it is 2ml square. Omega we know 20 by 3 radian per second is equal to finally 2 into ml dash. Then L dash is what? L dash is 1 meter only, into omega dash. Omega dash comes out to be 60 radian per second. So over here we see that is angular velocity has increased. So we see that is omega has increased. Omega has increased, even the rotational kinetic energy has increased, because some work is being done by both of these skaters. When they pull through this, when they apply a force and pull through this along this length, they have to do this work, and this work is used in increasing the rotational kinetic energy of this system about this axis, though the angular momentum remains same. So it is not necessary, that is when the angular momentum remains same, the angular kinetic energy, that is rotational kinetic energy, should also remain same.